Hello everyone. We are going to talk about our font style migration work called ClipFont in the next few minutes. The artistic font has become an integral part of visual media. However, it is difficult to design new fonts without relevant knowledge and skills. This task is relatively easy when the number of characters is limited. But designing Chinese, Japanese, and Korean characters presents challenges due to a large number of character sets and the complexity of glyph components. Existing methods implement few-shot font generation, inferring the styles of other characters by looking at some cases. But state-of-the-art methods still require hundreds of characters to be written, are still labor-intensive, and the generation quality is often poorer than the input examples. Additionally, most of the few-shot font generation methods can only realize the generation of monochromatic fonts in a specific language instead of word art. To solve these problems, we proposed a text-driven zero-shot font generation method for the first time, which can generate both monochrome and artistic fonts. The definition of style is no longer limited to manually collected datasets but is controlled by textual descriptions, enabling an almost infinite variety of possibilities. CLIP is a pre-trained model obtained by contrastive learning on 400 million image text pairs, which has inspired a series of text-to-image generation works. Recently, great progress has been made in text-driven image generation and editing based on CLIP pre-trained models. CLIP model has two encoders, one for image and one for text, that can convert images and text into the same embedding space by contrastive learning. ClipFont uses only the CLIP model as supervision and can handle any language text and symbols without fine-tuning on any font dataset. The style of the font is controlled by the text description, and the skeleton of the font remains the same as the input reference font. ClipFont optimizes the parameters of vector fonts by gradient descent and achieves artistic font generation by minimizing the directional distance between text description and font in the CLIP embedding space. Common fonts we use are stored in vector format for display at any scale without loss of quality. However, those fonts defined with very few control points are not suitable as the input of ClipFont directly, because the number of control points to optimize is too small, resulting in lack of generation details. Therefore, we adopt an enhancement strategy. Specifically, for each vector polygon, increase the number of control points on the boundary. In addition, vector polygon layers are stacked in the channel dimension to expand the parameter search space. Last but not the least, we apply a random color gradient to the input monochromatic font and divide it into multiple small polygons by color similarity. The loss function ClipFont use has three parts, which are clip recognition loss, directional clip loss, and similarity loss. Firstly, we use clip recognition loss to keep high-dimensional semantics and categories of characters unchanged. Secondly, we apply directional clip loss for texture generation and positive shape change. Finally, similarity loss can avoid results from becoming too cluttered. Therefore, our total loss function is formulated as shown in the figure. The gradients computed on the rasterized images are returned to the vector parameter space utilizing a differentiable vector renderer. To improve the robustness of the feature embedding of the CLIP model, text enhancement and image enhancement are proposed. Before calculating the directional clip loss and clip recognition loss, the image of the font undergoes perspective transformation and random cropping to reduce noise in text embedding. We also use a prompt engineering technique proposed by Radford. Experimental results demonstrate our method's state-of-the-art performance. Firstly, WordArt and monochrome font generation results are as shown in figure. Our font generation result is more like a decor style based on the input font. Different from the previous method, ClipFont can handle arbitrary languages and symbols. Due to the flexibility of natural language, we can also obtain an infinite variety of stylized fonts through a variety of text differences. Besides, we can choose whether to optimize the background color or not. Secondly, ablation study are as shown in figure. We can obtain the best results when we use all the proposed loss functions and enhancement strategies. When directional clip loss is removed, the model loses stylization ability. When removing clip recognition loss, characters in the result are hard to identify, such as the letter G, N, Q, and S. When similarity loss is removed, the results become cluttered and illegible. The last column shows the effect of removing the overlay enhancement strategy, resulting in a lack of detail and texture. Thirdly, compare with baseline because ClipFont is the first zero-shot font generation method. It is quite different from existing font generation in principle and effect, so a fair comparison cannot be made. Therefore, we compare ClipFont with the state-of-art method ClipStyler, which is a clip-guided style transfer method and can be applied to the font generation task as well. As shown in figure, ClipStyler only changes the background's color and generates limited texture, while ClipFont has the following advantages. Firstly, the results are in vector format and can be arbitrarily scaled without loss of detail. Secondly, the character produces a shape change that matches the text description. Thirdly, the result has more texture and detail, and can control whether the background changes or not. Overall, our contributions are as follows. Firstly, we innovatively proposed the ClipFont framework, which implements text-driven zero-shot vector font design for the first time, and models stylized font generation as a parameter optimization problem. Secondly, this paper proposes an effective vector font enhancement strategy to generate WordArt with color and texture. The clip recognition loss is proposed to alleviate the deformation of characters that is not conducive to recognition during the optimization process. Thirdly, ClipFont only utilizes the clip pre-trained model as supervision, without training or fine-tuning on any dataset, and can handle any language words and symbols. Thank you for listening.